Okay, now let's look at our square root function. So again, let's start with the generic root of x. If I substitute in -1, I get out nothing. Remember, there's nothing over here on the left side of the graph. If I sub in 0, I get 0, 0. There's one key point. 1, 1, 1. There's my second key point. 4, 2 is another one. 4, 2. And 9, 3. But 9, 3 isn't on this diagram, so for the sake of argument, let's just work with these 3 points. The domain of this function is x is greater than or equal to 0, where x is an element of real numbers. And the range of this function is y is greater than or equal to 0, and y is an element of real numbers. So again, we've started out with the basics. Let's go to our first example. Now, if I'm to remind you of what we did last class, think about where the negative symbol is. So here, the negative symbol is in front of the entire function. What do you think is getting reflected? In the second example, the negative is with the x. What do you think is happening? In the third example, I don't actually like how it's written. So notice I'm trying to trick you a little bit here. What I'd rather you do is make this equal to negative bracket x plus 5. So how does this third example, first off, relate to the second one where the negative is in front of the x? And then what do you think the plus 5 does? So what I want you to do is I want you to take a moment. I would like you to go to your transformations function. Here, I would like you to type in the square root of x. So notice, this is how you type it in. It says sqrt of x. So like I said, if you type in sqrt bracket x bracket, it gives me my generic, again, square root function. Notice my key point is this time at 4, 2. My transformed key point is at, again, 4, 2. So if I look at my first example, the negative sign is before the square root of x. Well, what does that mean you should be able to do? Well, if I do that, I want you to be able to change the a value. And I want you to change the a value to -1. Whoops, mine's a -1.25. There you go, -1. So what do you see happen? So the original, again, is in the red, and my transform function is in the blue. So you should see that it has been reflected in the x-axis. Well, does that make sense here? Yes, it makes sense because it's been reflected in the x-axis, so all the y values have changed. So again, reflected in the x-axis, so all the y values have changed. So it should now be at 0, 0, 1, -1, 4, -2, and 9, -3. And so if I draw my lovely sketch, okay, please verify that it looks like the one on the computer. It's the same thing. I want to write my new domain. My new domain is x is still greater than or equal to 0, and x is an element of real numbers. And this time my range is y is less than or equal to 0, and y is an element of real numbers. So if you give it a think here, what do you think happens when I now put the negative sign in front of the x value? Hopefully you're saying to yourself, oh, it's a reflection in the y-axis, and all the x values are changing. So take a moment right now, go back to your lovely graph here, change it so that the number here in front of the x value is -1. See what happens. All right, well, I reset my a value to 1, and I changed my quote-unquote b value, or my k value in this lovely computer program, to -1. Well, does it look like it's been reflected in the y-axis? Good, I hope so. And does it look like all the x values have changed? Amazing! So I go back to my notes, and I simply do the same thing. So it hits it here at 0, 0, -1, 1, negative 4, 2, and negative 9, 3. Here's my lovely reflection. My domain now is x is everything less than or equal to 0, and x is an element of real numbers. And my range here, my range is now still the same as the original, where y is greater than or equal to 0 and y is an element of real numbers. So before you go launching into this third example and you punch it into the computer program, think about it. What do you think the negative sign here does? And what do you think the +5 does? So give it a think, then punch it into the computer and see if your work is correct. Well, if you're smart, and I'm hoping that you are at this point in time, being in my class, this negative is the same as the one above it, so it gets reflected in the y-axis. And this +5 means it went to the left 5. So if I punch that into my handy-dandy computer program, here's what it says. So look here where my pointer finger is. It says negative outside and then x plus 5 in brackets. So notice it got reflected in the y-axis over here, and then it went 5 units to the left. Fantastic. So if I draw that here on my lovely diagram so that I have something to show for myself. Up. My diagram should represent what it is that I'm talking about. Okay, my domain is now x is everything less than or equal to -5, and x is still an element of real numbers. And my range is y is greater than or equal to 0, y is an element of real numbers. Awesome. Okay, here's my last example for the square root function. I would like you to try this example. First, think about it. See if you can see where my key points are going to go. Second, go to the computer. Try it out in the handy-dandy program. Third, come back here and verify. Okay, so again, if you had a smart moment, you noticed here the -3, that's with the x, moved it right 3 units. Whoops, sorry about that. There we go. Right 3 units. And this went down 4 units. Well, if I do that, my first key point went here at 3, -4, and then because there's no stretch factor, my other key points stay the same. Now, if I try my handy-dandy, lovely computer program, notice here I have in the blue, my transform function, it went 3 units to the right and 4 units down, so it is exactly what I think it should be. Now, let's take a moment and refresh. So if I have my generic point notation, my generic point notation says x comma y. Let's use this example here. This went x plus 3 and y minus 4. Let's try some key points. On the original function, 0, 0 is a point, 1, 1 is a point, and 4, 2 is a point. If I substitute into my transform point notation, I should get out the 3 transform points that I've listed here on my diagram. So 3, -4 is one of them. 4, -3 is the next one. And 7, -2 is the last one. So 1, 2, and 3. There are my transform points. So I'd like you to take a minute and write yourself a summary about what it is that we just did and how each of those values inside the square root function perform the. So if I want to take a moment and refresh everything I just did and take now my parent function of the square root function and apply to it the transformations I just did, here is my lovely point notation. My point notation tells me the transformation above, 3 units to the right and 4 units down. If I take my 3 general key points from the original function, 0, 0, 1, 1, and 4, 2, and I transform them according to this, I will get the points that I now have on my diagram, here, here, and here. So what I want you to do is I want you to take a moment. In that moment, I want you to sort of summarize what it is that we've just done and see how it is related to the point notation and the transformations that we did for a generic function. Then we will move on to the next type of function.